if we look at SW, so SW is going to be that blue segment, right? Okay, so SW, and then compare that to SF. SF is that red segment, right? So I've had people today, as we're trying to explain some of these, they made the comment that they take WS, and what ratio should WS be of the entire median? 2/3. So they write that SW is, and they say 2/3 of the median. Okay, that's what we know, right? That's what you just told me. So now we go back to Algebra 1, the first 2 or 3 weeks of Algebra 1, and we take these words and we put them into algebraic notation. SW, what does the word is mean? Equals. 2/3. Now of algebraically means what? Times. And now the median. Which one of these parts is the median?
FS.
Yep. So now we've got our equation, right? So now I plug in SW, I plug in SF, and we should be good from there.
I don't know why, but I did 2/3 SW.
Exactly, yeah, and that's the thing where, you know, most people are recognizing that we have to use the 2/3, which is good. We're recognizing that's the correct portion, but are we putting it on the right side? And once I create this, I'm always going to ask myself, I was going to go back real quick and say, okay, 2/3 multiplying something by 2/3 means it's going to get smaller, right?
Yeah.
Okay. Well, if I multiply that SF, which is this red segment, by 2/3, so by a number that's going to make it smaller, is that what we're going to get? We're going to get a blue segment here, right? That's what we want to do. We want to visually think about taking that segment and reducing its size. And the only way I can reduce its size is to multiply by a number between 0 and 1. Hold on a second. At this stage, and I usually wait until after I do my substitution, but is it okay to multiply by 3 right there?
Yeah.
Those 3's will cancel out, and then I got to multiply this side by 3, right? So it might be easier for some of us to write 3 SW's is equal to 2 SF's, and now when I plug things in, it minimizes the potential for fractions, right? I'm going to have 3x plus 3's, and we'll have 2, 6x minus 6's, and now we can do that algebra, right? Do we need to go further with the algebra? 9x plus 9 is equal to 12x minus 12, right?
Yeah.
Subtract 9x from both sides. Add 12 to both sides. X then ends up being 7. X is 7, then you can plug back in to find that that's going to be 24. Blaze, got a question?
Yeah. So could you just keep it as over 3 times that by -6?
Yeah, so you could go 3x plus 3 is equal to 2/3, 6x minus 6. And it's not terrible because of how 2/3 works with 6. Essentially, if either of these numbers or both these numbers are multiples of 3, this is going to work out real nice. 2/3 of 6, if you multiply it out, you get 12 over 3, which is just 4, right?
Yeah.
Okay. So we have 4x minus 4. This is going to be 3x plus 3. Subtract 3x from both sides. Add 4 to both sides. I still get the same, x equals 7. So yes, that's a very good question. I just know that some of us don't like dealing with those fractions that way. But it is, if you don't like dealing with those fractions, you know, that's a fair statement, but you're going to want to kind of force yourself to deal with them so that you get better at them. Because there are situations where they're not going to disappear, that you have to be able to manipulate them. If you continue